Okay, here's the graph of the function f, which is shown. So in the first quadrant of the x and y coordinate plane is given. There is one curve on the graph, and the curve starts at the point 0, 600. And then it goes down and right, becoming less steep, and it passes through the approximating points 10, 400, and then 20, 300, 30, approximately 250, and then it reaches a minimum point here at 4,200. And then the curve goes up and right, becoming more steep, and it passes through the approximate points of here is 5,400, and then it goes up to 6,700, and then becoming less steep, and it reaches a maximum at the approximate point of here, which is 7,900, where it changes direction and then goes down and right, and the curve exits the window at the point 8,800. Okay, so what we want to be able to do now is to be able to find the average rate of change of f on the interval from 10 to 60. So what we want to do is we want to find the average rate of change on the interval from 10 to 60. So we're going from 10 to 60 here. Okay, so what that means is we want to find out the following. F of 60 minus f of 10 over 60 minus 10. Okay, so our goal is to find out what is the output on this graph for when we have x equals 60. So at x equals 60, we can say that the output is approximately 700. So therefore we have 700 minus at 10, this is 10, and we would say that the output is going to be 400, so that's 700 minus 400 over 60 minus 10, and so that's going to give us 300 divided by 50, and 300 divided by 50 is going to give us 6. So the average rate of change is going to be 6. Okay, the next is saying to identify an interval on which the average rate of change of f is 0. Okay, now any interval that has the same y value at both endpoints is going to have an average rate of change of f, which is 0. So if you notice here, okay, here is a point where the output is 400. And then here is another point where the output is 400. So that means the interval is going to be in between 10 and 50. So we would say that the interval between 10 and 50, okay, would have the average rate of change of f is 0. And that is because if we take a look here, what is the output for when the input is 10? Well, the output is 400. So therefore, we have f at 10, which is equal to 400. And at 50, it's also 400. So at f of 50, we know that's also equal to 400. And therefore, those are this is the interval that represents the average rate of change of f is 0. Okay, let's take a look at part C. It says here, compute the following: f of 40 minus f of 0 over 40 minus 0. So let's go ahead and do that. So we have f of 40 minus f of 0. I'm going to divide that by 40 minus 0. Okay, so when our input is 40, what's the output? Well, the output is 200. So we know that that represents 200 minus, when the input is 0, okay, we can see that the output is at 600. And then divided by 40 minus 0, which gives you negative 300 divided by 40. And so negative 300 divided by 40 gives us negative 7.5 And so what does this value of negative 7.5 actually represent? Well, the value represents the slope of the line segment from 0 to f of 0 and 40 and f of 40, which means the same thing as, okay, we found the slope between the following values: 0, 600, and 40 and 200. Okay, in part D it says estimate the value of f prime of 50. Okay, well, what that says is it appears, okay, if we take a look at the tangent line at x equals 50. So here is the value where x is equal to 50. Okay, and it passes through the point 4,200 and 6,700. So here's 6,700. Here is 4,200. And we can see that this value here at this point is going to represent that tangent line. So again, at the line x equals 50, it appears it passes through these points. So therefore, we would find f prime of 50, which is then going to be the slope of that line. So that means that we're going to take f of 60 minus f of 40 over 60 minus 40, which is then equal to 700 minus 200 over 20, which is 500 over 20, which is then equal to 25. Okay, here let's take a look at E. It says, is f prime of 10 greater than f prime of 30? Meaning, is the slope at 10 greater than the slope at 30? Okay, well, the tangent line at x equals 10, let's take a look at that. So the tangent line at x equals 10. So when x is equal to 10, here is the tangent line. So we can look at what that tangent line is going to look like. Okay, And then we can look at the tangent line at when x is 30. So let's take a look at that tangent line. So let me use a different color for that. Okay, we can see that the tangent line at x equals 10 is steeper than the tangent line at x equals 30. So it is larger in magnitude, but less in numerical value. And what that means is the following. We would say that the slope at x equals 10 is going to be less than the slope at x is equal to 30. Okay, and so one way of looking at that is let's assign a slope value over here. So you can see that since this is steeper at x equals 10, we can possibly say that that slope is maybe -1. So if this is, at this point, you go down 200 and then over 10. So this would be -200 divided by 10, which would then give us -20 for our slope. Okay, if we take a look at this slope here, we may be going down, let me move that line up here just a slight bit here. Okay, so if we take a look at this slope here, all right, we're still going to go over 10, but we approximately may be going down a -10. So it's a lot smaller. So if we take -10 and then divide that by 10, then we get -1. Now this is just approximate, right? So if we would compare these slopes, right? So the slope at f prime of 10 is -20. Okay, which is that. And we would then say that that is less than the slope at when x is equal to 30. And that's -1. So you can see that -20 is actually less than -1. So therefore, that's how we're determining that the slope at x equals 10 is less than the slope at x equals 30. Okay, now it says, is f prime of 60, meaning the slope at 60, greater than f of 80 minus f of 40 over 80 minus 40? Okay, well, let's first take a look at that slope. So let's find that slope at 60. So at 60, there is our slope. So we're going to take a look at that tangent line there. Okay, and so that tangent line is possibly going to go down 100, so -100, and then over, say, 6, so to the left, -6. So if we wanted to find that slope, -100 divided by -6, and what does it approximately give us? So about 16.6. So we would say, okay, well, the slope right now that we have at 60 is positive 16.6. Okay, so now what would be the slope for the other part here? Okay, so let's compare. So we're comparing that. So what is f of 80 and what is f of 40? And then we're dividing that by 80 minus 40. Okay, so f at 80 is 800, so we have 800. F at 40 is 200. And then that's 80 minus 40. So that's 600 over 40. So 600 over 40 gives us 15. So that would be the slope there. So our answer would be what? We would say that the slope at f prime of 60 is greater than the slope at f of 80 minus f of 40 over 80 minus 40.